Okay, so this video is going to cover section 5.2. So in class, we went ahead and did this warm up. The big thing is we're using the conjecture we talked about in 5.1, which is the formula for the total number of degrees. So we got 180 times n minus 2. So the first step would be to look at each of these shapes and come up with the total degrees. And so this one is an octagon. If you plug in 8 to that formula, you get 1080. This one's a triangle, 180 there. And then these two, of course, are quadrilaterals. So you got 360 and 360. Now, the big thing with this one is using all of the things that we know here. If I know that all 8 of these angles are congruent, I can split that 1080 up 8 equal ways, and I get 135 for each of these angles. That would be the place to start with that one. Make a couple copies of that for you. Need to know those ones. They're all 135 though. Then we start using things like linear pairs. If I have 135 here, I know 135 plus 180 plus 45, is 180. So I'd get that one from there. This triangle is isosceles, so you've learned that. So that means that if the two sides are equal, then the two angles have to be as well. From there, I'm using my total. Once I know 2 angles, I can subtract from the total to get the third one. So there's 90 degrees up there. Now, from here, we're going to start looking at anytime you know all of the angles around a full revolution, those have to add up to 360 degrees. So if you look here, oops, I don't want to do that. No fill color. So if we have those 3 angles there, we would know that those 3 have to add up to 360 degrees. Well, 360 minus 90 minus 135, that is 135 as well. And then we've also got 2 equal angles there. So that gives us that 135. Now, if this quadrilateral has angles that add up to 360 degrees, 180 minus 360 minus 135 minus 135 gives me 90. And since these last 2 angles are equal, that 90 degrees is split equally between them. So we've got 45 and 45. And then our last one here, same deal with our full revolution, 135, 135. What's left over to make the full revolution? Well, it is 90. Now, technically, we don't know enough to know that the rest of these are 90, but they are going to be 90. We'll be talking about that pretty shortly. It's got 4 congruent sides, so it is a rhombus. And if one of the angles is 90, then all of the angles will end up having to be 90. So that was our first one there, using the conjecture we learned yesterday, along with things like linear pairs, angles adding up to 360. You'll also see things like vertical angles, isosceles triangles, things like that. The other big thing was anytime you know all of the angles are equal, splitting that up equally with division is going to be something you can do a lot of. Or if you have 2 remaining angles that are equal, subtract to find the total of the 2, divide by 2 to find each one. That only works if they're equal, but that's going to be pretty common to see that. Okay, next up, we took a look at the homework. I know I didn't assign all of these. These are left over from a year before this. So we started on number 3. So number 3 here, 4, get myself out of the way, 5, 6, 7, and 8. If you're using the online book, which hopefully you are, these little H's that show up are hints. You can just click on those and they will give you a hint on how to do that one. Definitely a really good resource. If there's any of these that you are not getting right, remember, these homework assignments are not graded. The whole point of this is to learn. So if you're not getting one of these right, you need to be asking, because doing them wrong or not doing them at all or copying them to get them right, all are about the same thing and that you don't understand the concept. So if you're missing one of those and you're not seeing why, ask. Send me an email. Put the picture in there and be like, hey, how did you find E on this one? I'll be happy to help you out. Okay, so today we are moving on to section 5.2, which is the exterior angles of a polygon. Yesterday in 5.1, we talked about the interior angles. Today's exterior angles, which are the angles on the outside. We've already learned one exterior angle conjecture with triangles learned that the exterior angle here is equal to the sum of the two remote interior angles, those two there and there. Today, we're going to talk about something that's true for all polygons. All polygons. So, one last thing before we get too far into this. When we talk about exterior angles today, we're talking about a set of them. And a set of them is formed by extending each side of the polygon once in the same direction. So you see it kind of makes that pinwheel shape. The big thing we are not able to do is we can't ever have more than one angle at each vertex. Technically, this isn't too much of a problem, but we're talking about exterior angle sets like this, or this, or this that kind of look like a pinwheel. They're extending in one direction. So here's what we did in class today. We started off with a triangle, and we drew those exterior angle sets on it. And we started off actually by measuring the interior angles. So I'm going to go ahead and just kind of do that here real quick. I'm going to use arrows. So there, there, and there. And then we measured two of the interior angles. Today we did something a little bit different than yesterday, where instead of measuring all three, since we know they add up to 180, we're just going to use math to find that one. So this one looks like it's right at 80 degrees. That one up there. Looks like we've got 47 degrees. And then handy dandy Mr. Calculator, 180 minus 47 minus 80 degrees is 53 degrees. So 53 in our last one. Now, today we're concerned about the exterior angles, right? So in order to find those exterior angles, we're going to use our linear pairs conjecture. So I've got my calculator over on my other screen here. I'm not doing these in my head. So that means that this one has to be 127. This one would be a 100. I can do that one in my head. And then our other one here, 180 minus 47, is a 133. So those are our exterior angles. I'm going to go ahead and highlight those in green. Those are the ones we're talking about. And so if I add all of those up, then I can figure out what the total for the exterior angles is. And we get 360 degrees. So we do that around the whole class. We hopefully find out that everybody's getting that same 360 degrees. And then the question becomes, what about our other polygons? What about quadrilaterals? What about pentagons? What about 15-sided polygons? And so I usually have everybody make a conjecture here. A lot of people tend to think that just like with the interior angles, we think the exterior angle is probably going to go up too. Reasonable assumption to make here. But let's go ahead and take a look at what happens here in some of these other ones. So here I've got a quadrilateral. Bring this in here. Got a quadrilateral. I've got all the angles. And if I add them up, you're going to notice they're still 360 degrees. But even more importantly, what I want you to look at is take a look at kind of the sizes of these compared to the sizes of these. So there's one more, but they're all just a little bit smaller. They're not quite as big overall. Then if I were to go back and look at pentagons, you're going to notice kind of the same idea here. Each angle itself, like on average, they're all a little bit smaller, but there's more of them. If you double check, they all still add up to 360 degrees. So I do want to take you through and just kind of look at one of these and maybe think of a different way of talking about it. Oops, that's the wrong page. Sorry. I want this one. So here we go. I've got a triangle here with all three exterior angles marked. You notice they all go in the same kind of clockwise direction. Watch what happens when I slide this slider. I'm just taking those angles without changing them, sliding them together, and you'll notice they make 360 degrees. If I take my quadrilateral and do exactly the same thing, you'll see they still do it. even if I change the angles a little bit, they still work. They still add up to 360 degrees. I'm not sure why that one is looking weird, but I think I have to redo it with there we go. Same thing with any of these. Here's a pentagon, 360. And one thing that I think helps to see this even more is what happens when I take these shapes, this is a quadrilateral, and I just shrink it down. Shrink it, shrink it, shrink it, shrink it, shrink it. And you'll see once I get the entire shape shrunk all the way down, those 4 angles, in this case for a quadrilateral, just make that full revolution that we talked about in the warm-up. And of course, the same thing is going to happen with our pentagon. If I shrink it down, those 5 angles are just the 5 angles that make the full revolution. And you can kind of see that here. I can't do it on the board, but you get the idea, hopefully. So our conjecture for this one is the exterior angle sum conjecture for any polygon, concave, convex, any number of sides, the sum of the measures of the exterior angles is 360 degrees. Every single time. Doesn't matter how many sides it has, doesn't matter at all. It's a little harder to see with the concave one, but it still works. So that is the conjecture. Make sure you get that written down in your conjecture sheet. And let's go ahead and just do a couple of quick examples here. We're going to start off with this one. So this is about as easy as it can get. So here we've got a pentagon with 4 of the exterior angles and 1 missing. So in this case, all we really have to do is just do some subtraction. I'll bring my calculator in here. I'm just going to close that. You don't need to see me anymore, do you? So I'm going to bring my calculator in here, and we will start subtracting. So we're going to take, there we go. So we'll take our 360 degrees minus 72 minus 87 minus 49 and minus 67, and we'll hit enter and see what's left over, and it's off the screen, but you get 85. So use a calculator. Don't do this all by hand, but there's something you can do, finding the missing angle. Other examples, go ahead and put that down. If I had something like a quadrilateral, let's say I had a quadrilateral. Now, I'm not always going to get the interior angles exactly. So sometimes I might have something like this. If this angle is 135 and this angle is 75, and maybe I even go ahead and say that this angle and this angle are equal, what is that angle? So there's a lot to go kind of look through here, but we can still use our exterior angles. We just don't happen to have them all this time. So I've got this 75, so I'm going to have to start over here. I know the 135 is the interior angle, but I've got a linear pair. So 180 minus 135 gives me 45 degrees. I have to go over there for the outside. That's the one I'm really concerned about. Now, the other thing here is if these 2 interior angles are equal, what do you think's got to be true about the exterior angles? Well, of course, they have to be equal as well. So I know that this one is x as well. And so now I can use the exterior angle conjecture. I know that my total is 360. And I can take away the 75 and take away the 45. And I get 240 left over. But that's the combined total for both of these. So because I know they're equal, now I can just take that answer and divide it by 2, and I can find out that each one is 120 degrees. So kind of using some of those ideas from other areas. So your homework today is going to be a little bit more mixed up. If you're using the online book, it is page 270. Right? If you're using the real book, then I think it might be 269. So you're doing 1, 3, 6, 7, and 9 through 11. I know it's kind of all over the place, but I kind of picked some good ones that show me, if you can do those, you've got the really big ideas. There's some in here that are more challenging, like 6 and 7, not so bad. 9, 10, a little bit harder. And then 11 is your proof. So to me, if you understand how to do 6 and 7 really well, maybe you can get started on 9 and 10, you're in a good place. If you're having trouble with like how to do 6 and 7, that's definitely a good sign that you might need to ask for some help. So take a look at those, see how you're doing. Let me know if you have questions, and hopefully I will see you soon.